So, in this lecture, we are going to understand what is the meaning of reading on of weighing machine. Okay, how to find the reading simply. Clear? So, reading of the
Yes, sir.
given weighing machine. I think this topic you are familiar with that, like in your home. When you are going to weigh something, like then how do you weigh? For example, one gas cylinder. Okay, if you want to weigh whether it is properly weigh properly, like it is a gas is filled properly or not, then you are going to weigh that. Then how do you weigh that? You are using such type of instrument in olden days. Clear? Such type of instrument you are going to use. And I just want to give little bit clarity. So how do we measure the way of any load? I'm not saying only cylinder. Okay, any load. So you are fixing a load here. Okay, this is a load in this hanger. You are fixing a load here. Then after this, it is going to stretch. This pointer, can you see this pointer? This arrangement? This
Yes,
pointer
sir.
little bit displace. For example, here. Okay. If you increase the weight, this pointer is going to displace. Clear? If you take a spring balance, then the spring is coming out like this. It is going to extend. Inside this weighing machine, there is one spring like this. Inside that, I just want to give a little bit clarity regarding the instrument. Inside this instrument, what is there? Where there is a spring like this. Okay. Now here you are going to put one weight like this. Let us suppose its mass is m. Clear? You are putting that weight, but you don't know what is the mass. Then with the help of this weighing machine, you are going to calculate the mass. How much mass? Clear? 2 kg, 5 kg, 10 kg, 12 kg. Can you see this
Yes, sir.
on vertical line? This is the calibration. This is what? This is known as calibration. Calibration means this is written calibration, calibrate. Okay. Corresponding how much spring is going to elongate, we are calibrating how much weight it will be. Clear? Manually, how do you do? Like if I ask you, shall I move to the next slide?
Yes, sir.
Okay. Just see in your mind. Now, one thing, like one more thing. Can you see 50? Maximum is 50. Means more than 50 kg you can't put. If you put, the spring will break. This is already they have written. A spring balance is used to measure 50 kg. Maximum 50 kg you can weigh. Okay. Understood?
Yes, sir.
Now see, this diagram, it should be in your mind. Clear? When I'm going to explain, this diagram should be in your mind. Clear? Because whenever we are going to learn physics, then we should compare with our day-to-day life. So I just take this example. Now see, this is such type of arrangement, like also you have seen. Here there is no spring, you will say. You just put a weight here. What you are doing, you just place your books. If you place your books here, then it will give the this is known as dial. Okay, this is dial. This dial is going to rotate. Clear? Inside, what is the mechanism? You are not going to bothered. Simple. Clear? What is happening inside? We are not bothered. Little bit. Clear? How this pointer is going to move, I will explain. Simply, when you put some weight, this pointer is going to rotate. And when this pointer is going to rotate, for example, it rotate like this. Clear? When this pointer is going to rotate, it will give how much reading? 30 kg. This is 30 kg. You will say its mass is how much? 30 kg. So always remember, you are not going to what actually here reading like calculation part you will understand later. First, we will understand the meaning of weighing machine, how it is going to work. That is our first understanding. Clear? Now see, such type of arrangement like you have seen that. Clear? Like you are going for a vegetable vendor, you have seen like they are using a weighing machine, to weigh the vegetables. Clear? Nowadays they are using electronic weighing machine. I'm having. Can you check? This is also a weighing machine. It is visible uh, properly. I think I don't know. But if you stand here, if you stand on this, I think it is more visible now. If you stand
Yes,
here,
sir.
yeah, if you stand here, for example, like this, here, I'm increasing my little bit force on this. You can check. Initially, its reading is 0. Clear?
Ah,
Its reading is 0. If I increase the force on this surface, on this surface, if I increase the force, if I stand here like this, you can check its reading is going to increase. It's a electronic, digital. Okay, this machine already like mainly like doctors are going to use. Clear? When they are going to weigh the weight of a person, the person is standing on this weighing machine. So he is standing on a platform. Then this is giving the reading, how much it, 20 kg, 50 kg, 70 kg. This reading is given by that like doctor. Clear? He is saying your weight is 70 kg. Clear? Understood? 60 kg,
yes,
70
sir.
kg, whatever else. Clear? So what here? There is, you will say, sir, there is no spring here. Then how the weight is going to measure? So he is standing on this platform. Then what he is doing? He is what he is
Applying
doing.
pressure on that.
You can say pressure and one thing, normal reaction force. Normal we love normal because his foot is in contact with this platform. Clear? When he stand here,
Yes, sir.
when he stand here, if I place my mobile like this, then it is giving me some weight. Understood? So what my mobile is
Yes,
doing, what the person is doing, he is standing here. Normal reaction force. Normal reaction force is responsible here for giving the reading. Clear? On this, if you increase the normal reaction force on this platform, then it will give more reading. Understood?
yes,
Clear?
sir.
Any
Yes,
doubt?
no doubt, sir.
Okay. Because on this platform, you are, if normal is given by the platform to you, then you are also giving normal to the platform. Clear? Then because of this normal, there is some reading in this electronic way. You can check.
Yes, sir.
Understood? Up to this, any doubt? Clear? Any doubt? Any doubt? Okay. Okay. See. Now see one more thing. Like I think this is clear to you. So whenever I'm saying like reading of a weighing
Yes,
machine
sir.
means simply normal reaction force. Clear? Understood? Now see. This is spring balance. Inside the spring balance, we have a spring.
Yes, sir.
Initially, its reading is 0 because no load is here. Understood? Now, if you increase the load, for example, you increase the load, and because of this, let us suppose you have attached a mass 2 kg. Then how much spring force, or you can say tension, if you draw the free body diagram, it will be like 20 down and up kx, that is spring force. Because now it is in equilibrium. I know it will oscillate, it will come to rest after a little bit time it will take. I'm saying when you attach a mass, it will come to rest after a certain time. But spring will elongate because of this weight. Now this spring is going to elongate. It means it has certain spring force here that is going to balance the weight of a object. Gravity is pulling this weight down, but the spring is applying a spring force that is k into x. F is equal to kx, or you can say F. No worry. But there is some like opposite force acting on this block, that is spring force that is applied by the spring on that. Now because of that, it elongate. It elongate how much? How much it elongate? Let us suppose how much x from initial position. That's why spring force is kx. Now if you increase the weight, let us suppose you increase the weight. So what I have explained, like weighing machine is the normal reaction, or we can say normal between machine and a body kept over it. So whatever is the normal between a machine means weighing machine, and a body kept over it. That's all. Clear? So reading will be normal by G. With the help of example, I will explain this topic. So practical, I think you have understood. Actually, I want to give more practical, but like if you look at such condition in your daily life now, then you have more understanding in physics. Physics is just understanding of nature. That's only I can say. Now see, write one question. With the help of this question, you will understand. Find the reading of weighing machine. Question is, find the reading of given weighing machine. Clear? Now draw this diagram. First, this block is in the lift. This person in the lift. Okay, this is a weighing machine. Weighing machine. Okay, and a person is standing on this. I have drawn here like this. Clear? So how much reading he will see here in this case, and one more case I want to draw. Now this lift is moving with certain acceleration. You have to tell like reading of weighing machine in all these cases. Lift is going up with 15 meter per second square. 15 meter per second square here. Now what is the reading here? Person standing here. Clear? Simple. Find the normal reaction force between a body and the weighing machine. One more case here. Here, our lift is going down. It's 15 meter per second square. So with the help of this example, you will understand how the weight of a person is going to vary. Clear? How much actual weight? Here also, like he's standing like this. Okay. Here mass of a person is given 60 kg. Clear? Mass of the object is. Then tell me the reading of weighing machine. Draw the free body diagram in all the cases. Look at first. I will solve first, then you watch it. If you draw what actually weighing machine is going to measure, weighing machine measure normal between a machine and a body capped over it. Now this is the body which is capped over the weighing machine. Then weighing machine, if you draw the free body diagram of this person, then here in this case, weight is down, m into g, 60 into g is 10. Normal will be like this. In this case, second case, if you are standing on the ground, if you draw the free body diagram, 60 and normal up. I just take n1. Why I take n1, I will explain. Okay. Here, I just want to explain like n1 n2 different thing. Like in which case, like more reading, less reading. Just look at here. Here, m into g and normal is up. You can take n2. Now, this is according to a person on the ground. This person is there and he is standing on the ground. According to him, I'm going to explain all these cases according to a person who is standing on the ground. He is the observer. Clear? He is an inertial frame, that side induced pseudo force. Or else you can use. He's standing on the ground. You can draw x and y here also. In your mind, if you draw x and y like this. Clear? Now see. All these in all the cases, find normal. First case. First case, what is the value of normal? Lift is at rest. Up, normal is up, minus 60. Mass of system into its acceleration. Lift is at rest. So how much normal action force? 600 Newton. Then my question is 600 Newton is the correct answer? No. Clear? Then what is the reading? How much reading is given by the weighing machine?
600 newtons.
Very good. 600 by G. Normal by G. How much? 60 kg. Actual weight. Clear? Reading simply means normal by G. He is saying I am 60 kg. Okay. Any doubt? Normal by
No
G.
doubt.
Clear? Second case. Second case, like what is the value of n1 here? N1. If you write Newton's law of equation, Newton's second law of equation, then n1 minus 60 m into g. Lift is going up. So mass of system, its acceleration as seen from the ground, 15. Now tell me in this case, what is the value of n1?
Is it 690 newtons?
How much? 1500 Newton. So will you say like it is reading? No. A reading will be R2. N1 by G. 1500 by G is 10. 150 reading. And something divided by G, always understand it is what? Force divided by acceleration is what? Mass. Clear? So its unit will be
Okay.
kg, 150 kg. Clear?
Yes, sir. I got it.
R3. R3. Third case. Third case, if you calculate the value of N2, if you find like N2, weight is down 660 into G. Mass of system is 60 into acceleration. Acceleration is down, so minus 50.
Minus.
So what you will get? Minus, what is that like? How much? Minus 900 plus 600. How much?
Minus 300.
Minus 300. Is it possible like normal reaction force negative?
No, sir.
Is it possible? No. I think in foundation classes also have explained this. If normal comes out to be negative, it means here normal
Downwards.
reaction is zero. The person lose a contact. It means that this weighing machine on which a person is standing, what he will feel weightless. If this lift is going more than the acceleration of gravity down, then this person is feeling weightlessness and he will lose the contact and he will die. How? This person will lose the contact. How? What is the situation? I will show you. When he lose the contact more than 10, it means normal is negative. You tell me, if you take G acceleration, if this lift is going down with a 10 meter per second square, then this normal is zero. Okay. So at 10 also, his weightlessness more than 10, 10.1, 10.2, this normal is negative. So even the person is going down with a like more than like G or exactly G, then he is feeling normal reaction is zero. He will lose the contact. Clear?
Yes, sir.
Understood? Understood?
Yes, sir.
Clear? Now 600 is 1 minute. Okay. Give me 1 minute. I think you understand. Okay. Then what will happen? This person lose the contact and he is moving. He's flying like this. He will strike the top surface. The person is like this. His head will strike the top like this. He will lose the contact. Weighing machine is here. Then if there is no normal, normal is when you're standing on the weighing machine. If you are not standing on the weighing machine, then in this case normal is zero. Zero by G will be how much? Zero reading. There is no reading. No reading here. No reading. He will fly. He say I'm weightlessness like gravity. There is no gravity. There. He is going like that. He is going up. Clear?
Yes, sir.
Now tell me like why is he like I know like he will be like he will lose the contact. Then lift is going up down very fast. Then his head is going to strike and he will die. That's why lift should move slowly. Its acceleration should not be very fast. This condition like because when you are standing even in the lift, if this weighing machine is not there, still this weighing machine is helping us to know like this way. Okay, but if you increase the like a person mass is 60 like here 60, if you increase like more than 60, for example if a person is very heavy, will he move up? No. If you increase the mass of a person like 100 kg, then this and lift is going down with a 15 meter per second square. Is it possible like normal to be there is normal
No, sir.
negative? Is it possible? No. So heavy person is there also. Like it depends on the this condition also. Like what I'm
Acceleration.
saying. Yeah. acceleration. For this, in this case, he will feel weightlessness at this condition. Okay, understood?
Yes, sir.
So when normal is zero, simple means in the reading is zero. If reading is zero means weightlessness. This is known as weightlessness. He will feel like I have no weight. He will swim in the sky like weightlessness. He has no weight. Like this, he will feel. Okay. Now, same question, like if I ask like this, if a person lift is going down and lift is going down, for example, 15 meter per second square, and this is a weighing machine, and person is very heavy. He is very heavy, like this. Okay. Now, if I increase its, let us suppose its mass is 100 kg. Okay. Like even I just want to explain, like, is it possible? Like here I am increasing, there also, like I just want to check because I am saying, but mathematically it is correct or not. Let me check because even I don't know. Let us suppose if a person, I am checking like whether it is possible or not. If I increase the mass of a person, is it possible? N minus 100 into G, 100 into 15 is down. Oh, in this case also, like, sorry, like
Sir, not possible, sir.
minus 1500 is still
Not possible.
negative. He will fly. Weightlessness is still. Hey, orally, when I'm saying no, orally, that is different. But when we do the mathematical, na, mathematics never give the wrong answer. Normal is negative here also, like because mass both side it is going to increase now. So what we have found, like, and here like n minus mg is equal to what? Minus m into a. So n will be what? M g minus a. Okay. In this case, in the third case, what we this is the equation. Third case. If a is greater than or equal to g, then normal is zero. Reading is zero. There is no reading. Simple. Clear? Second case. Sorry, third case. Third case. In the third case, we found this equation, na? Clear?
Yes, sir.
You can derive by your own. If this lift is up, then a plus a, n minus mg is equal to plus ma. Then n will increase. If n, you just tell me what actually, if you look at in all these examples, first case normal reaction force 600. This is true weight. You can say weight or mass. Actually, don't confuse here. Like if you multiply by g, this is like uh, a weight. Clear? Understood? If you divide by
Yes,
g,
sir.
it become what? Mass. Clear? So don't confuse mass, weight, nothing. If you divide normal reaction by g, then it become mass. 60
Mass.
kg. Clear? Now, in this case, when the lift is not moving 600, okay, normal. Normal is going to increase when the lift is going up. Normal is going to increase. You can check 1500. When normal is going to increase means there is on this platform, there is more downward force on this weighing machine. You are pressing more, very, very heavily this platform. Then this platform is going to give the more reading. More reading you will see in this platform. Okay. So if you decrease the value of normal reaction force, then reading is less. If you increase, reading is more. That's only the concept. Clear? So what is normal here?
Sir, I think you're on mute.
Okay. Is my voice audible now?
Yes, sir.
Clear? So this normal, actually this normal is going to increase. First case normal is 600, then 1500. If you again accelerate very, very heavily in upward direction, and this normal is going to increase. But downward direction, if you want like safely, if a person is a you want like he should move safely, then acceleration should not be more than g, or it should not exactly equal to z also. Otherwise he will feel weightlessness, or maybe possibility that, not possibility here, like normal, he will lose the contact when lift is going down with very very fastly, then he will lose the contact, strike the top 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 surface of the lift, and he will die. There already we have understood, like even if you increase the mass of your person is very heavy, still he will die. He will lose the contact with the, and lift is coming down, he will die on the spot. So when you increase the normal reaction force, it means that you are increasing the normal force on this weighing machine. More the normal reaction on this weighing machine, more the reading given by the dialer. Here, like digitally, you can see, you can check digitally. Clear? Understood? Sometime like
Yes, sir.
there is dialer also. So in the next lecture, I will explain the numericals, some more numericals, because slowly we have to move, and slow, believe me, I'm saying 100% sure, after learning this much, then revise only, revise the notes, no question from outside. Clear? Only from my notes. If you revise this much na,
Yes,
you
sir.
can crack any exam, believe me. Honestly, I'm saying this concept actually I taught in such depth everywhere, like if you check, like they will directly take a numerical and solve. Yeah, but actually, I want to show you practically, because you are learning this concept first time. And your first question, your quest means search. Your first quest should be like you should look at what is inside the weighing machine. Inside this weighing machine, what is the instrument? What is that inside this weighing machine? So that it is going to give this like 70 kg, 15 kg. It is going to that. Okay. Then you have to search that. There. So in case of weighing machine, always find normal reaction force. In case of spring balance, find the tension or spring force. Clear? So today's lecture is
Yes,
finished.
sir.
And if you have any doubt, still I'm saying, please ask me. You can ask me, okay? And prepare for
No
your board
doubts.
exam sidely. And don't take any tension in physics again. I'm saying slowly you definitely, because everything takes time. Nobody reach a like Himalaya, we are saying that, in one shot. It takes time. Okay, it takes time, lot of hard work. You know, diamond, you are looking diamond, you are getting diamond, it is not easy to for like to get diamond. Lot of hard work is required. Clear? Lot of pressure, because of increase intense pressure, our, you can say, like plants, animals, like waste, you can say billions of years like it takes for forming coal and diamond, those things like minerals which you are going to see now. This is from, it takes time, lot of pressure is there. That's how we are digging out. So hard work, everything is hard work. Learn from nature. Learn, nature is also growing because of hard work. Trees will not grow suddenly. It takes time. When you water, even if you are not giving water, they will grow. They will grow slowly. Then when it grows properly, then it is giving fruits. Okay. When you provide sunlight properly, water, then it is giving fruits after a lot of hard work. So practice, and believe me, nothing is tough. Just easy practice, and whatever question like it comes, when any question like numerical, any like which you are thinking like, sir, how is it this, like at this age such question will come, and you have to write, make one diary. This I'm giving one practical example. Follow, make one diary, small diary. On that diary, write your question, whatever question comes to your mind, like how is this, like I'm not understanding this question, write that. Clear? And in the same diary, like this practice actually I'm giving because mostly like students are following that. In that diary, write your mistakes also, like when you are solving question, where you are making mistakes. Clear? I have explained this concept now today. Tomorrow I will give you the some examples like we will solve. Now you have to practice this question because this concept will fix in your mind once you practice. So concept application like that we are going to move. That is only like G Mains or NEET. If you whatever else exam we want to crack, we have to move like that. Practical, how much practical you are there, because CBSE like theory is there, but application part is less. I'm not saying like that is not good. That is also good. Without theory, like you can't learn numericals or concept. Okay. So thank you so much. Like how is the studies like board examination preparation is going on? Okay. Is my voice audible due to some network issues? Okay. I will move. Now see, it's clear like
Yes, sir.
spring is going to extend. If you increase the load, for example, initially you applied 2 kg. Now let us suppose you increase the load, then what will happen? It is going to elongate further. Let us suppose you are increasing to 4 kg. You increase the mass, then it will elongate more. Clear? Then there is some more elongation.
Yes,
X1.
sir.
Now if I ask like spring force will increase? Yes. When it is at equilibrium, then 40 down, spring force K into X1. So initially spring force is Kx is equal to 20. Clear? 20 down, 20 Newton. Then when you increase the mass, then it will be 40 Newton. Clear? Understood? Now when you are increasing the mass,
Yes.
when weight is going to increase, you can check. Then spring force is going to increase. That's why there is, you can check here. In this diagram, if you increase the load, if you increase the load, then what will happen? Spring is going to elongate more. When spring is going to elongate more, this pointer, this we say pointer. Okay, can you check this there is one sign, this is known as pointer. This machine definitely in your home, you can check. This pointer is going to move, it is going to displace in the right. When this pointer is going to displace, that correspond, for example, pointer is stopping here, then you can check the reading. How much? 80 kg, 18, let us suppose. Then you say this load is 18 kg. Clear?
18 kg.
Okay. It's
Yes, sir.
how much? 18 kg. That's only. Any doubt like? So weighing machine like there are two. One is spring
No, sir.
balance.
No
In a
doubts.
spring balance, simply the reading. Who will give the reading? Simply spring force. More the spring force, more is the reading. So actually, what we are doing, we are going to calibrate. What we did, like if you look at carefully, when mass is, for example, like downward force is 20 Newton. Clear? When spring force is this much, corresponding to this 2 kg. Clear? 40 Newton. Corresponding to this, how much? 4 kg. Clear? For example, 150 Newton. Corresponding to this, 15 kg. This is what we are looking now. At the back. Check this diagram. Here 18 means spring force is 180 Newton. Clear? Understood? So we
Yes,
are
sir.
going to calibrate. This is known as calibration. If you again increase 200 Newton, if you increase spring, then it will be 20 kg. Then we make a machine like a spring balance. I just attach one spring here and one pointer like this, and correspondingly I just calibrate like 2 kg, 4 kg, okay, 15 kg, 20 kg, like this. This is known as calibration. So corresponding to a spring force, I just calibrate how much. Clear? Understood? 4 kg, 2 kg, 3 kg, 5 kg, 40 kg. Understood? Any doubt like up to this? Any doubt?
No doubt, sir.
Okay. This is in case of
No,
spring balance. If you look at spring, simply find the spring force. That's only. And divide by G. You will get the reading. Okay. Reading. Reading means the reading that is given by the instrument. Okay. The reading that is given by the instrument. Clear?
instrument.
But if you look at such type of instrument here on this platform, you will find such question like a person is standing on this platform. For example, this is bottle, my bottle. Clear? This bottle, I have considered one example. On this platform, it may be a person, and you will find such question. This bottle and this weighing machine. This is weighing machine in my hand. This is weighing machine, and this weighing machine is placed in the lift, and lift is moving. Tell me the reading. How much this weighing machine is going to read? Then if you find such question here, the weighing machine is going to read normal reaction force. Clear? Reading of weighing machine is normal reaction force. Simple. Later we will, when I'm going giving the theory part, I will definitely write. First you understand here normal. Because the person is standing here, he is going to push. He is going to press this. He is pressing more. When it is when this person is in the lift, then he is pressing more or it may be less. Clear? Because normal reaction force is going to vary. You tell me, if you stand here, gravity is pulling the person, and this platform is giving normal reaction, and the person is also applying normal reaction force on the weighing machine. If you draw the free body diagram, if you draw the free body diagram of a weighing machine, this is the weighing machine. Clear? And if a person is standing here, then if I draw the free body diagram of this person, this is a person. Clear? If I draw the free body diagram of this person, then its weight, if I draw separately, like this, I am into G.
Weight
And
downward normal
very good. And
reaction
the
force
platform, because
upwards.
it is in contact, so it will give normal reaction force. N. You can say N1. But this person is also, if I draw the free body diagram of this weighing machine, this is the weighing machine. Weighing machine. Clear? Now, if I draw the free body diagram of this weighing machine, I'm saying like mass of weighing machine is less. Now on this on this weighing machine or platform, this is platform, okay, on which it is going to stand. This is known as platform. Clear? Now on this platform also, this person is going to apply normal reaction force like this. Clear? Understood?
Yes, sir.
When he is going to apply the normal reaction force on this, in the car, how do you accelerate a car? With your foot. There is certain arrangements are there. Same way, because of normal reaction force in car also you are going to accelerate. Clear? Your foot is in contact with a
Yes,
certain
sir.
arrangement. You're going applying brake and whatever else. Same thing here. This normal is going to push this platform. Because of this normal reaction force, there is certain any arrangements inside the weighing machine that is going to press. When it is going to press, for example, when it is going to press, then what is going to happen? Look at this. Look at this diagram. When it is going to press with a normal reaction force, then this dialer is going to move like this. It is that dialer is going to rotate. Inside there is some arrangements. Okay, clear? Understood? Any doubt? Like clock.
Yes,
In the
sir.
clock,
Not also.
who is going to provide energy? There is a cell. Cell is providing energy to a
That.
clock, and clock dial is going to move like this. Okay. If you will not put any weight, if you will not put any weight on this, there is no reading. Clear? No reading. It means something is there who is rotating this dial. Then who is that? Normal reaction force. Understood? Any doubt? See, I will
Yes, sir.
explain numerical
Not
later.
also.
Simple weighing machine, normal action force. Spring balance question, you will find only spring force inside that spring. Okay, that is the reading. Divide by G. Why we are going to give divide by G? Because our instrument is given, like if you find normal reaction force is 1500 Newton, then 1500 Newton is not the clear. Understood? What the reading is given by the instrument? 150 kg. Understood? So that's why we are going to
Yes,
divide
sir.
by G. Nothing else. Understood? This is just an introduction
Yes, sir.
of weighing machine. I just want to explain here. Now, write down this category, such type of category problem we are going to discuss. And please write with a numerical. Right. Write down the question. Simple. Concept is there. Reading of weighing machine. Reading of weighing machine. Weighing machine. Normal by G. Normal reaction by G. Clear? One question, please write. Or you can write a concept also if you want to write. Weighing machine. Weighing machine measures normal between normal between don't write B/W, write full between. Okay. So weighing machine measure normal between machine and a body capped over it. Weighing machine measure normal between machine and a body capped over it. Clear? Any doubt? Tell me.